All right, let's go ahead and look at this last example. We have our limit as x approaches infinity of the square root of x squared plus 1 all over x. Our process whenever we see we have a limit going to infinity is to divide out by the highest exponent or degree in the denominator. However, the denominator is 1 here, so there is no variable in our exponent. So what we must first do is multiply by the conjugate. So we have the square root of x squared plus 1. And then remember the conjugate, the sign in between is what changes, so plus x. And you multiply that to the top and the bottom. And we go ahead and we're going to multiply out or FOIL the numerator. When I take the square root of x squared plus 1 times the square root of x squared plus 1, I have the square root of x squared plus 1 squared. There's 2 of them. Then I would have plus x times the square root of x squared plus 1. Then minus x times the square root of x squared plus 1. And then lastly, negative x times x would be negative x squared. All over my denominator, square root of x squared plus 1 plus x. Now the nice thing about the conjugate is the middle terms will cancel. Okay, and then the square root and the square will cancel as well. So I am left with x squared plus 1 and then minus x squared from over here. So if you want to, when you guys multiply out by the conjugate, you could just jump to this conclusion. That would be okay. The x squareds will cancel, so I am left with my limit as x approaches infinity of 1 over square root of x squared minus 1 plus x. Now that I have my limit going to infinity, I am going to go ahead and divide out by my biggest degree in the denominator, or biggest exponent in the denominator. The square root of x squared, you guys, would really end up being x. Okay, so I see I have an x to the first here, so I'm going to divide out by x here, and then my equivalent underneath my radical would be x squared. So I'm going to divide everybody out by an x squared. And I also need to go ahead and divide my numerator by x. Okay, so I have my limit as x approaches infinity of 1 over x. I got my x here. And then I would have the square root of, I'm taking out an x squared, so I'd have 1 minus x squared. And then plus, I'm factoring out an x, would be x times 1. Now from here, you guys, I'm going to take the square root of my x squared, which gives me an x term. I'm going to bring it out in front, and so it's going to be the absolute value of x. In the bottom, you guys should notice this is a positive x. I'm going to factor out an x from here. So I have my limit as x approaches infinity. I have x, and then I have 1 over x in my numerator. Now I'm factoring out this x. So I will have x, and then I will have the square root of 1 minus 1 over x squared plus 1. The x's will cancel. Okay. And now I have my limit as x approaches infinity, 1 over x all over the square root of 1 minus 1 over x squared plus 1. Now I'm going to think about my limit as I plug in infinity. 1 over infinity, or any number over an infinity, approaches 0. So this will approach 0. This part right here is 0. So what do I have? I will have 0 over the square root of 1 plus 1. So I have 0 over 2, which is 0. So that is my limit for example 9.